Okay guys, so right now we're going to do a lesson on similar triangles. Okay, similar triangles have the same angles or the same shape, but they are different sizes. But they're different sizes. For example, these two triangles are the same shape, but different size. This one might be 4 by 6 by 3, and this one it might be 2 and 1.5 and 3 here. And you can see this one's bigger and this one's smaller. It's smaller by about half. Obviously not to scale, but same shape, different size, and all of the sizes are bigger or smaller in proportion to in the same proportion. Okay, so all sides are bigger or smaller, in the same proportion. So you can see where we're going with this is because we did the similar ratios, we can do the similar proportions here to try and do some more math related to that. So what we're going to do with this information, if we know that similar triangles have the same basic ratio between the side lengths, we're going to use that information to find unknown side lengths in some of the triangles. Okay, so we're going to erase this. Okay. So if we had one like this, triangle like this, okay, and let's say this was 14, this was 20, and this was 7, and this one here is 10, A and B. Okay, so these two triangles are similar, we'll say, because we know that this angle is like this angle is like this angle, and this will be given to you. They'll tell you in the question that the two triangles are going to be similar. But the first step that you do here is you set up ratios. Okay, so we're going to say A is like 7, A is like 7, 10 is like 14, it's like 14, and B is like 20. So B is like 20. It is very important that you don't get these mixed up. Don't put A here and then the 7 here, because you have to keep one triangle on top and one triangle on bottom. Okay, so keep the measurements of each triangle organized. Okay? That can be a big problem for some students. Okay, so keep them organized. Now all we're going to do is we'll erase this. I'll give you a second. Pause the video here if you need to copy any of this down. Alright. Now we have step 2. We use ratios to solve for the unknown sides. Okay, so here's all we need to do is remember we had A over 7 equals B over 10 equals, well, B over 20, my mistake, equals 10 over 14. Okay, that's what we have. So we're going to take these two and we'll solve for B. B. Okay, we're solved for B. So we end up with some cross multiplication. B times 14 equals 20 times 10. So I end up with B times 14 equals 200. And then we're going to times by 14 on one side. We want to get B by himself, so what we do is we move the 14 over and we do the opposite thing. Instead of times, we divide. And B is going to be equal to 14.3. Okay, so now we know this value here is 14.3. Now we can solve for these two Now, since we know B, we can solve for A. Okay, we know A over 7 is going to be like 14.3 over 20, and we got this since we just solved it in the previous problem. So 7 times 14.3 equals A times 20, and 17 times 14.3 is going to be 100.1 equals A times 20. Divide by 20, okay, so we end up 101. Divide by 20 equals A. We end up with A is equal to 5.001. Okay, so that's how you use similar triangles to solve for unknown sides. The homework will be in the description of this video. Thanks for watching.